Recently, I got this Microbit Smart Cutebot, a DIY programmable robot car kit from Elecfreaks. So let's go ahead and start the unboxing. Aligned following MAPE. I was really surprised by their user guide. If you just follow this user guide, I don't think you will need to visit any other website. This is because everything related to the robot is explained in it. Not only that, but it also explains how to write your first program and how to run it. There are lots of examples covered. AAA batteries holder. This is the BBC Microbit is an award-winning programmable device. It's small, low-cost and easy-to-use microcontroller developed by the BBC British Broadcasting Corporation in collaboration with several partners. The Microbit is designed to make coding and electronics accessible to students, teachers and hobbyists. This is the new Microbit v2.21 version and it features a micro USB connector to use with PC for programming. You can program it with Makecode, Microblocks, JavaScript and Python. Reset and power button, battery connector, BLE antenna, a microphone, microprocessor ARM Cortex M4 CPU upgraded from a Cortex M0 at 16 MHz to a Cortex M4 with a floating point at 64 MHz, a speaker, accelerometer and compass and edge connector for accessories. On the other side, we have a microphone indicator, a touch logo, 25 programmable LEDs, 2 buttons and the pins are labeled as 0, 1, 2, 3 volt and ground. Memory has increased by 700% from 16 KB to 128 KB RAM and 256 KB to 512 KB flash, which gives the device much more capability. The board can provide 200 mAh to accessories, up from 90 mAh in the previous board versions, and it can support both AI and machine learning. HC-SR04 ultrasonic sensor. And finally, here comes the robot chassis. It's really a cute bot. Its design is so attractive. This is a power switch. These are I/O expansion ports. IR receiver module you can use an IR remote controller to control this cute little robot. 2 fully enclosed GA12-N20 DC micro gear deceleration motors with speed up to 300 RPM rotations per minute. A battery port, a buzzer, edge connector for the Microbit board. This is the I2C interface. Over here, we connect the HC-SR04 ultrasonic sensor. These are the 2 RGB headlights. On the bottom side, there are 2 rainbow LEDs, a pair of tracking sensors and a universal wheel. Let's assemble these parts and then we'll start the programming. You can assemble this robot in less than a minute. Don't think of it as just a toy car. It's a development kit. By practicing with this robot, you and your children can greatly improve your programming skills. To get you started, I will first run some basic codes on this robot. Anyway, the Smart Cutebot is ready. So let's start the programming. Open the makecode.microbit.org website. Click on New Project. Give your project a name. Click on the code options and select blocks, JavaScript and Python. You can also select Python only or JavaScript only, but I'm going to continue with the first option. Finally, click on the Create button. Let's first take a tour of the editor. On the left side is the Microbit simulator. See what your code looks like running on a Microbit. This is our toolbox. Drag out blocks of code from the toolbox categories into the workspace. This is the workspace. Snap blocks of code together to build your program. Once your program is ready, click on this download button to download your program onto the Microbit. With this share button, you can create a link to your project to share with others. So that's all about the editor tour. To add Cutebot in the toolbox, click on the extensions. Search for the Cutebot and click to add it to the toolbox. Now, if you click on the Cutebot, you will see the Cutebot blocks. Now, using these blocks, we can control the motors, headlights, we can monitor the state of IR sensors, we can monitor the ultrasonic sensor, we can control servos, and by using the IR module block, we can control the robot using an IR remote controller. Before I'm going to start the programming, first I would like to share some basic information with you guys. You can see these two blocks, on start and forever. These are similar to the setup function and loop functions in the Arduino. So on start is an event that runs when the program starts. Use this event to initialize your program. As I said, forever is similar to the loop function in the Arduino programming. So if you want to run a part of your program continuously, you can place it in the forever loop or event. Unlike other programming languages, you can also add and delete comments. Apart from this, you can duplicate blocks, and if you need help, simply click on the help and then you can read about that block in detail. If you want to delete any block, simply select that block and while holding the mouse left button, drag it to the toolbox and release the mouse left button. And if you want to do it quickly, then simply select the block and press the delete button on your keyboard. To add a block, go to the desired category in the toolbox, select the block and drag it to the workplace. This was some basic information that I wanted to share with you so that you don't waste your time exploring these basic things. Before starting programming, connect your robot to your PC or laptop using a micro USB port. Once connected, you will see a message. If not, then you can go to the settings and click on the connect device and follow the instructions. Anyway, the Cutebot is ready for the programming. Let's first control the RGB headlights. I want that when I turn on the robot, it should first display red, green and blue colors one by one with a 1 second delay. Then, when it goes into the control forever event, it should display different colors with a 100 millisecond delay. Let's do it. Next, we are going to control the Cutebot DC motors. We are going to control its forward, backward, left and right movement at different speeds for different time durations. So let's do it. Next, we are going to use the DC motors and headlights altogether. I want the headlights to stay off when the robot is moving in the forward direction, and I want the left and right headlights to act as the indicator lights when the robot takes left and right turns. Next, we are going to use the ultrasonic sensor. I want the robot to stop when it detects an obstacle. Let's do it. Now, let's convert this into an obstacle avoidance robot. I want the robot to turn to the right when it detects an obstacle. Let's do it. So far, we have covered headlights, ultrasonic sensor, and DC motors. Next, we will learn how to use these 25 LEDs, and we will also use these push buttons and touch logo. First, I will remove the ultrasonic sensor so you can see the LEDs and push buttons clearly. Using this block, you can draw any custom icon. To display numbers, you can use the show number block. For ready-made icons, you can use the show icon block. To print any message, you can use the showString block. To display different arrows, you can use the showArrow block. Next, we are going to use these buttons to display custom icons. For this, we will use a condition. Let's say if the button A is pressed, I want the cross icon to display. Else, I want all the LEDs to remain off. Let's do it. This means if button A is pressed, then show this cross icon, else turn off all the LEDs. Next, we are going to use the logo, and let me tell you, its use is just like the push buttons. If the logo is touched, I want to display this icon. Else, I want the center LED to remain on. Now, let's use the gesture block. You can see we have different types of gestures. Simply select the one you want. In my case, I'm going to go with the shake gesture. I believe I have covered pretty much everything about this robot. There are so many other examples in the user guide that you can try to further improve your programming skills. We will try the line tracking lesson from the user guide. The Cutebot has 2 tracking sensors which help it to move along black and white lines. It can also be used to detect the edges of a table. This is the complete code. When the tracking sensor on the left side detects no black line, set the speed of the left wheel to be faster than that of the right wheel to correct its movement. When the tracking sensor on the right detects no black line, the speed of the right wheel has to be adjusted slower than that of the left in the same way. When both tracking sensors detect black lines, move forward at an even speed. Let's upload the code. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in the next episode, and thanks for watching.